So today is the 19th. It's Monday, July 3rd, 2017. I hope you had a great weekend. Okay. So if you hadn't noticed, I'm not in the classroom right now. You know, you might it might seem very interactive. It might seem live, and I think I might be there as a spectator. But we're doing a distant learning opportunity today. So let's see what kind of advantages we can take. See what opportunities we can take advantage of. So continuing with where we left off from last class, again, this lecture 19 is Monday, July 3rd, 2017, 8:30 a.m. to 10:15. So let's see, we're looking at example 6. Okay, it says sketch the contour map of this function g of x, y equal to x squared minus 3y squared. Now, we didn't do this last time? Okay. So it asks us to sketch the contour map. Okay. So then I think when we were doing it, we were choosing different values. So when we're doing the contour map, we set the z or the output function to a constant, and then so we want to fix it. When we were doing the vertical slices, we would fix one of our inputs. Now that we're doing the contour map, we fix our output. So we fix the output for different values, and then draw the traces on the same map, and that's what the contour map is. So I'm gonna copy this to another page and continue. So I'm just gonna take this and copy. Let's get a better copy. So let's go here and copy, and I'm just gonna continue down below, and we'll keep this page here above as a reference. Let's paste. Go here. That's too big. So let's take a look at this, and I think this flow might work a little bit better than what we've been doing. All right. So if we're looking at this example 6, and it says, suppose we just started with this question. It says sketch the contour map of this g of x, y, and we have this. So now if we're doing the contour map, we fix our outputs. So let's try to generalize. Now we could continue what we did last time, like if the output was 0 and then get the contour. Let's try to generalize a little bit. So let's do like 3 cases. Let's say let g, what is it? We need to say okay. So we'll start with this opening. All right. So the level curves occur when our g of x comma y is equal to some constant. So we're going to do different values of our constant c. So then let's say let c, like say we set it equal to 0. We're going to do 3 cases: when our output is 0, when it's positive, and when it's negative. So we'll try to look at those notions. Okay. So then now if the output is 0, so then we would have x squared minus 3y squared equal to 0. Now I'm not 100% on identifying it as like either like a ellipsoid or a plane or anything like that nature. But I know in this form, like, okay, when I see this, I see x squared minus 3y squared. I know I have my x squared and my y squared. Now I'm thinking it might either be like either a circle or an ellipse, or it could go the opposite direction because of that minus and be some kind of hyperbola or something. So if I just had to follow my intuition, I might try, solving for y, and then, seeing what that graph looks like. So I would just graph this in my 83 plus to get a sense. So I'm going to solve for y and graph that and see what happens. I'm just playing with my intuition if I didn't have anything else to work on. So if I solve for y, I would add that to both sides. I get x squared equals 3y squared. Divide by 3, so then y squared. Oh, shoot. I think I do have to charge this because it was low. I forgot to charge it. Let me see. So then, if we divide by 3, we'll get y squared equals x squared by 3, and then take the square root. So we'll get y squared equals x squared by 3. And then, so y would be plus or minus root x squared by 3. Okay, let's just graph that just as is, and see what happens. Okay, so we have our virtual calculator ready. Now we got this y equals plus or minus this radical here, so let's just get a sense of what's going on. So if we took the positive, we got square root. It's going to be x squared divided by 3. Okay. That's that. Then the other one is negative square root x squared divided by 3. Now, we can't always do this, but this is a place to start. And again, we could pull up our list of 3D objects and, because you should have a sense that it could either be a circle or an ellipse or, what is it called? Hyperbola, where it goes in the opposite directions, but I feel like this is the easiest way to kind of go about this for right now. So then I'm gonna just do a standard window. So 6. All right. So we're getting this kind of graph. I think that's a hyperbola. So, which makes sense because when you look at the square root, we got the square root of x squared, and that's going to be absolute value of x. So this is plus or minus root 3 by 3 times the absolute value of x. Okay, that's a number larger than 1. So basically we have, some number between 0 and 1, so a number less than 1 times the absolute value of x. And so for positive at the top, since it's a number between 0 and 1, that means our absolute value is going to be compressed or squished. For instance, if we just look at the top one, so let's suppress the negative. Okay. So the top is just going to be like it's 1 over the square root of 3 times the absolute value of x. So that's going to be a number between 0 and 1 times the absolute value of x. So that's going to compress our absolute value of x. So that's going to squish it. So that's fine. And then when we look at the negative, it's just going to be the same thing but flipped over the x-axis. So this actually makes sense. Okay, so when c is 0, we get the two absolute values. Okay, let me see. Now it says sketch the contour map. Okay. So when c is 0, we get those two absolute values. Okay. Still need to be charging. So from here, we can just do a quick sketch. And I'll go ahead and show the simplification. This is going to be plus or minus 1 over the square root of 3 times the absolute value of x. So when we say the square root of x squared, that's absolute value of x. The reverse, the square root of x squared is non-negative, so as far as the domain. But this one, you end up with absolute value. Okay, so then the graph ends up being just a quick sketch. Let me do my graph paper. It's usually better when I do that. So just a quick sketch, nothing drawn to scale. So then, for this first one, we'll get a third, so something like this, like that, and like that. And then we also get like this. like this, where this is our positive x, this is our positive y. Okay, let's see. And let's kind of clean this up a bit. So we're gonna get rid of that and be consistent. 1, 2, 1, 2, so something like that. Okay, so that's when our c is 0. So now think about it. We have a three space object. Now when we fix our output to be 0, and we look at the trace, we get this kind of image. So when we cut it, when the z is 0, we get this image. Okay, so this is like the trace when c is 0. Now let's try to consider when c is positive. So say we had a positive constant, something greater than 0. So then let's say c was strictly greater than 0. Okay, so then we would have what, x squared minus 3y squared equals some positive. Okay. I think I'm going to try the same technique. I'm going to try to solve for my y and see what kind of image I get. Okay, we should get something mimicking this. So I'm going to add the y and subtract the c. So then I'll get x squared minus c will be 3y squared. So then y squared would be x squared minus c over 3. And then you would take the square root and plus or minus. So then y would be x squared minus c over 3 root plus or minus.